of MAT2611. Can you hear me?
Yes, sir.
Okay, fine. So, welcome to the course of MAT2611. Today is the first session of this course. In this course, we have the course outline and the tutorial letter where all the things are described. Also, the assignments and all things are defined over here. And as you know that the prescribed textbook is the Howard Anton, the book by Howard Anton, which is the Elementary Linear Algebra with supplementary applications. It's the 11 edition. You can also follow its 12 edition. So this is the prescribed textbook, and the topics, the study plan is accordingly follow here. Where the outcomes and assignments dates are mentioned. So these are the topics which we need to be covered regarding the sets, then functions, then vector spaces, then subspaces, linear transformations, then bases, dimensions, and then after that the eigenvalues and eigenvectors, decompositions, linear transformations. So these are the important topics of a linear algebra, which are the part of the syllabus of this course. So today is the first session, which is based on the problems of a set theory and the functions. So we start our session on that, and we also describe some problems of a this MAT 2611 plus, as well as we will describe certain examples of functions and sets. So basically, this session will be start from the sets. It's important to understand the theory of a set because in a linear algebra, we normally need to work on different sets and then sets with the some of spaces which are like a vector spaces and subspaces. So need to be described that what is the difference between space and a set. So there are certain things regarding that, and one by one we will follow the things. Basically, set is the collection of a well-defined and distinct elements. For instance, if we take some like a collection of well-defined and distinct elements, for instance, if we say that we have a set A which contains certain elements, for instance, we can make some finite elements one, two, three. So this is the example of a set. Similarly, the set of names, the set of a city is the set of distinct elements we can take on that. Sometimes we can say that there is a set B, which is a some set or interval from 1 to 2. It means it contains the elements which is a continuous set from 1 to 2, where 1 and 2 are also the element of that one. You can also write this into the form of a scientific form. For instance, we can say that it contains all the elements of from the set of real numbers, such as we can say that the one is here, one is the element of that set for all those x where one is less than equal to x and is less than equal to the 2. So this is the also notation of that set. It contains all the real numbers from 1 to 2, where 1 and 2 are included. The above set A is only the 1, 2, 3, which means that A is a discrete set. Sometimes we have a finite set, infinite set, so there are the several form of a set notations. In this course, like in a tutorial letter, you will see something about set, but you can also see its different examples, and also the material you can found anywhere from any textbook. So but it should be cover the topics which are described in the tutorial letter or described in these files. Now this is the set A and B. Also we have the several other examples of a set. For instance, we can make some set of R is a important set, which is a set of real numbers. Like it contains all those elements which are from minus infinity to the plus infinity. So this is the set R. We have this set. Also, R square is a set contains all the, we can describe the other sets. For instance, R square is the elements or collections of all two tuples elements. For instance, it contains all x, y, this type of elements, such that the elements x and y are the real numbers. Like these are the real numbers. So it's a basically here is the set of two tuple collection of all two tuple elements. Similarly, we have some other notations. The set of integers. For instance, if we say that the z is the set of all those integers which are coming from, like, say, up to the it contains -3, -2, -1, then 0, and again 1, 2, 3, up to so on. So if we it contains the elements, uh, all the elements of a set of integers. So similarly, we have set of natural numbers 1, 2, 3, up to so on. So these all are the examples of a sets. And then in the set theory, we have some other form of a set as well, like the set of integers are sometimes will be denoted as a, this is the notion of a set of integers. And also we have a set of rational numbers, set of real numbers. So set of real numbers are all those elements which can be write into the form of P and Q. So these are the some different form of a sets. Similarly, here we can describe some other kind of sets. For instance, if we say that we have a set, like there are some examples, like the set of all even integers. We can describe as a x belongs to the z because that contains all those elements. If we say x equal to the 2y, where y is an integer, it means it contains all the elements like 0, 2, 4, 6, 8. So set of all even integers can be described in this way. Then also we can define the set of odd prime numbers, which are the all natural numbers, such that x is equal to 2y plus 1, where y is, belongs to set of natural number, and x is the, in this way x will become, x is the prime, so it will contains all the odd prime number. So there are some other important notations we can describe. Also the set of cities with population more than 1 million, we can describe like some cities of that one, city A, B, C, whatever. But the important thing is that the set is the collection of all well-defined and distinct objects. So it's very important that we need to see the form of a set. For instance, if we describe some sets which contains the infinity, it's important to see that in R the infinity is not discluded. Like it's an interval. Basically, if we see that it's a collection of all those elements for which the minus infinities and infinities are excluded. For instance, we can say that it has all those numbers, for instance, all those x, such that we can say minus infinity is less than x and is less than the infinity. So here one thing is important, that why we exclude the infinities from set of real numbers. So this is the very important thing. And we have also another set which is called extended real numbers. But that set, if you will focus on this, that from R, why infinities are excluded, there is a one important thing, because it doesn't fulfill, if we include the infinities on that, then it will not become the it will not contain the distinct element condition, because we know that infinity plus 1 is also infinity, infinity plus 2 is infinity, infinity minus 1 is infinity. So but it's contained all the element which are distinct as well. Distinct element mean infinity is not the part, because infinity is equal to infinity plus 1, which is equal to infinity plus 2, up to so on. So it means it contains the chain of that element which are not distinct. So that's why we excluded the element infinity from that. So this is the important thing, that we are taking R as a uh, all those elements where the minus infinity and plus infinities are excluded. There are also some other form of sets are described over here. For example, X is a set of real number where X square equal to 1. So we need to see that what kind of elements contained over that. X square equal to 1 mean if we put minus 1 square is 1 and 1 square is also 1. It means this set is a discrete set having only the two elements from minus 1 to 1. And for if X is the set of integer for which X minus 2 and x is less than minus 3, it means greater than strictly greater than minus 2 means from start from minus 1, 0, 1, 2, and up to 3 is also included, because 3 is also equal, as well as 3 is the set of element from the set of integer. And furthermore, here we have a x is a set of natural number where x is equal to 2y for some y belongs to the n. Now, if we see that what kind of elements are included over here, so if you can see that 2, 4, 6, this type of element will comes into that set because it's contain the all those elements which x is the uh, element set of all even numbers. Then we have the two things about sets. Like one is the element of a set, and the other is the subset of set. We can describe these notions over here, as well as we will see some other details regarding this. Okay, so there are the difference between the sets and its elements. For instance, if we say that the element and subset, there are two kind of notions. Like we can say that a belongs, a is a, or small a is the element of a. It means that uh, this a element of a is the element of a, or belongs to the a. For instance, uh, the example, like if A is a set having 1, 2, 3, then this one is an element of A, but not the subset of A. Like the subset means like if we describe another set, like suppose that if this is we call a B is a set having the one. Then we have noticed that A contains 1, 2, 3, and B contains only the one. So B is the subset of A, but not the element of A. And it's a trivially thinks that for every set, there has at least two subsets. One is the empty set. Empty set is a subset of every set. And the second is the set A is also a subset of A. Every set is itself is subset of A. One can notice that there are proper subset and improper subsets. For instance, one can say that one belongs to the A, but this one is a proper subset of A. Proper mean that there are also some other elements which are in the set B, but not in the set A. Which are in set A but not in set B, because B contains also the 2 and 3, A contains also 2 and 3, but the B contains only the one element A. And here it is important to note that 1 is not equal to this one. This one mean there is a set which has an element 1, but this one mean only the single element. And on the other hand, we can say that 1 belongs to the 1. This is true, like because uh, this one is the element of this set. And there are also another important thing about that. If we say that A belongs to the B, then it means that this set A is the element of B. And one can say that this we can take if some bracket on that, then this will becomes the subset of A. And since if A is a subset of B and B is a subset of C, then there is a transitive property will also hold for that. It means this A is also a subset of C. But this A is not a subset of C because A is an element. And there is a difference between element and set because the elements always belong and set will always be contained or be the subset. Set will be the subset of the other set. Now, the difference between these notions, like we can say that A is contained in B, and this A belongs to the B. So there is a two different things, and one can see the relationship between that. So if we say that this A belongs to the B, this means that the entire set A is a single and distinctive element of set B, or the entire set A is an element of B. For example, we can consider the two sets like A is a set having 1, 2, 3, and B is the set whose first element is a set which contains 1, 2, 3, and the other elements are 4 and 5. It means B contains the three element, A also contains the three element. Now let us assume that 1, 2, 3 to be x, like this we say that x is like uh, x is equal to 1, 2, 3 because this is shows as an element. Now if x A equal to x, then it means B is equal to the x 4 and 5. This means that the entire x or the entire set A or x belongs to the set B, such that set A is a single distinctive element of set B. So because the B contains several elements and A is only the part of that. So in this way, we cannot say that this A is a subset of B, but the only we can say that A belongs to the B. So there are several other notations now will be agree that if like if A is a proper subset of B, then A does not belongs to the B. And when A is not the element of B, then A is a A is not a subset of B. So there are the relations, and one can be verify this result, which will always be hold. And it is important to see that when the element belongs to a set and when the element be a subset of a set or not subset. This means A is not a subset of B. It's sometimes we call it's an improper subset. Improper mean it is expected that A can be equal to the B because we as we say that has a every set is a subset of itself. Like A is a subset of A, so it means that both can be equal. For example, and this is also one thing important that if we have a set A, if like A is a suppose the proper subset is the improper subset of B. Like it means that A can be equal to B or A is a subset of B. If this is hold as well as let me put the condition. If A is the subset of B and B is the subset of A, then A is equal to the B. This will be always true. Because the both conditions will be true in that case. And there are also several properties of a set, like if A is a subset of B, B is a subset of C, then A is also a subset of C. The transitive property is also hold. And if it's still not clear, let's one can make several other examples regarding that. Like if we have a three sets A, B, C, and A belongs to the B and B is a subset of C, to identify whether A is a proper subset of C is 2 or not. Like one can see that if A is a set having one element only, and B is a set which contains a set A, which is the only element, one element of set B, and small b is also the element of set B. And C is another set containing a set A, that A is A belongs to the B. You have to be noticed that this A belongs to the B, and this A also belongs to the C, because this A is also the element of set C. And on the other hand, we have to see that this B contains the two elements which are also the part of its set C. So it means B is a proper subset of C. Now one can see that if we denote this A set by X, then we can say that X is A is equal to X, B is equal to X, B, C equal to X, B, and C. Then clearly it is one can see that this A also belongs to the C, and A is not a subset of C, because this A is an element of a C only. So the A is a proper subset of C is false in that case. Now, you can be understand that the element belongs to the set cannot be the subset of this. So here, this relation one can be verify that if A belongs to the B, then A is not a proper subset of B. So also there are some other things like some other form of sets we have. For instance, if X is A is the element, A is a set which contains all those elements of set of real numbers such that x square is equal to the 2. It means that we need to check that which kind of elements contains that satisfies this condition, because the first type, first side will taking the all those element, and the right side we put the condition of on all those x whose square equal to the 1. And we notice that if we put square root of square of minus square root 2 if we take, and square root of 2 if we take is the square of both element, then it will becomes the 2. So the only two elements are satisfying this condition, which are minus square root 2 and plus square root 2. So it means the A is a set, is a discrete set having these two elements. Similarly, we can see that if A is a set which contains all those real numbers whose that are greater than and equal to 0. It means that this is a set starting from the 0 up to the infinity. Like this is basically the entire line we can obtain from that. And see, there are also certain properties of that one. The union of two set is a set, intersection of two set is a set. So one can we take a union or intersection of that set. For instance, if we take, we define what is the A union B in that case. For instance, if we compute A union B, we have to notice that in this way we obtain a set like the under root 2 is also the part of the B, but the minus square root 2 is not the part of that set. So it means that we can say that this is the collection, this one union the another interval which we contain from 0 to the from 0 to infinity. So this is the union of two sets. While in the intersection, if we take the all those elements which are common in both sets, so minus square root 2 is that one. A minus B is the only minus square root 2, and B minus A contains all those elements which are in A, which are in B but not in A. So we can remove the other elements from the set B, because B is the interval from 0 to infinity. Just remove the element which is common in the B and A. So minus square root 2, like we can see that it is basically uh, we just take b minus a, we can compute and get the answer, because it will remove only the those elements which are in b but not in a. And also there are some other sets, like one can see that there are some examples like A contains all element x belongs to the Q whose square is under root 2. Q is a set of all rational numbers which can be write in the form of P over Q. This set is an empty set. So we can make certain proof of that mathematically. For instance, if we can use the contradiction method of mathematics. Suppose that x square is equal to 2, and since x belongs to the Q, it means every element of Q can be write as a over b, where a and b are two natural numbers. Now, by cancelling of common factor, we assume that a and b are relatively prime. Like a and b cannot be further cancel, or not be further. Both are the relatively prime numbers. It means that the only integer that can be divide both numbers, a and b, are plus one and minus one. Now, since x square is equal to 2, it means that we can write this as a over b whole square equal to 2. It means a square equal to the 2b square. And this means, if you will see that if a square equal to the 2b square, it means that every element of a square is the 2 times of b square. It means uh, a square is a even number, because every element of a square is the 2 times b square. It means a square is an even number. Since the square of an odd number is odd, then it means the a square is of the form of a 2 times r. It means if we take its square root, then it's also equal to, it's be the even form, like a is equal to the 2r for any number r, real number, any integer r. Now, this implies if a is equal to 2r, one can put this thing in this equation, like a square equal to 2b square. And we can see that after taking square, the 4 times r square equal to 2b square. Now, by cancellation of the 2 from both sides, it will becomes 2 r square equal to the b square, which means that is the element of a 2 times s, because b square is the even number. So if b square is an even number, because b square is the equal to the 2 times r square, 2 is the even number, and every number multiply with the 2, it will becomes even number. So if b square is even number, then b is also the even number, and b is equal to some 2 times of s. Now we have noticed that a is equal to 2 times r, and b is equal to the 2 times s, which means that 2 is the common factor of a and b. But initially we assume that a and b are relatively prime. The only integer that divides both a and b are plus 1 and minus 1, which contradicts the initial assumptions. It means there is no rational number x in the set Q which satisfies x square equal to the 2. It means A is an empty set. So this is about this one. And furthermore, these are the relations we already described about that one. And these are the questions about that we can see regarding that one. And similarly, this we also saw that if A is contained in uh, B and B is contained in A, then it means A is equal to B if and only if. And if and only if one can see the relation that is described over here. This is the basics of a set theory. Furthermore, there are some other examples of a set, like if A is a set contains all the integers where x is equal to 2 times y minus 2 for some y belongs to the z. And here B is also the set of x equal to x belongs to the set of integers where x equal to the 2z for some z belongs to the capital set of integers. Are they both equal? Here, if you see or describe that set, A contains the all those integers which are the even integers, plus 0, plus minus 2, plus minus 4, and also B contains the all those elements which are in the form of 0, plus minus 2, plus minus 4. So hence you can see that both sets A and B are equal sets. Furthermore, there are some certain form of relations are hold. We can see the union of that one, intersection of that one, A minus B, B minus A. We have already seen that one. And these are the sets which we are saying that this set A is empty set. Now, if B is a set of any all those x where x square plus 1 equal to the 0, you have noticed that if you put the minus 1 square, then it will becomes 2. And if we take minus square root of a minus 1 square root, then it will satisfy because minus 1 square root square plus 1 equal to 0. But notice that x is the set of a real number, and a real number cannot take the imaginary element. So the complex number is not allowed. The only x is the element, which is the set of a real number. It means this set will also consider as an empty set. So this B is the empty set because there is no real number whose square plus 1 equal to the 0. And similarly, there is no natural number. If you make it square plus 1 is strictly less than 1. So C is also the empty set. And here these are some the operations or laws which are hold in set theory when we can see, and also you can see these laws uh, from any elementary book of a mathematics or set theory which these laws are hold. These are also some the identities which will be hold in the case of a set the hold for every set. Like if you take any set A, B, C, so the following laws will be always hold. So the next thing is about the Cartesian product and the power sets. So if you have the two sets, so we can define A cross B. A cross B means the all collections of A B order pairs where is coming from the A and B is coming from the B. For instance, if we take A is a set 1, 2, 3 and B is suppose a set 1, 2, then we can make A cross B which contains the six element 2 multiplied by 3, and the first element will be the 1a, second element will be 1b, the third element will be 2 comma a, then fourth element will be 2 comma b, and then the fifth element will be 3 comma a, and the sixth element will be 3 comma b. And similarly, b cross a, we can define the first element in the order. The first element will be the element of a b, and in the second place, the element of a. Both contains the sixth element because 3 times 2 is 6, but a cross b and b cross a are not equal. Like 1 comma a and a comma 1 are not equal. So it means the a cross B and B cross A are unequals. Now here how many elements? So A cross B, as we say that if A contains n number of elements and B contains the m number of elements, so A cross B is will be equal to n multiplied by m times elements. And then the next thing is about uh, the power subsets of X. Power subset is actually the collection of all subsets, all the possible subsets of X. P of A means all B's which are the possible subset of A. And remember that empty set is the empty set is always the subset of each set. So, for instance, we can define the power sets of A. If A is a set having 1, 2, then the all possible subsets are 0, 1, 2, and 1, 2 itself, because 1, 2 is also a subset of uh, set 1, 2. So it means the power set of A contains empty set, set A, set 1, set 2, and set 1, 2. So it contains the four elements. If there are two elements, then it will becomes four. It means the number of elements of a power subset of A is the 2 power n. It means that if there are three elements in any set, then the number of elements in power set of A will be 3 square. Sorry, 2 square, 2 power 3. If three elements, then 2 power 3. If four elements, then 2 power 4. So in this way, we can also say about how many number of elements in the power set of any set A. So we can determine the if phi is an empty set, then P of phi we can define, and also if A is a set having the one element, then we can also compute the power set of A. As remember that the number of element will be how many? The 2 power 1, because there is only the one element. So it means it will if 2 power 1 is means 2. So P of 1 is equal to the empty set and this set 1. So it means P of A contains the two elements. The one is empty set and the other is the one set. Here there are three elements, so the total number of elements are 8 because 2 power 3. So first is empty, then 1, then 2, then 3, then 1, 2, then 1, 3, and then in the last 1, 2, 3. So there will be the total 8 elements or 8 subsets of this P of A. Now, similarly, one can compute the power set of a phi and power sets of a phi and this. So please remember that this phi is a set and this is a set contains the phi. So they are the difference between that the elements are always belong, and the set and the other set will always a subset of each other. So then there is an important some paradox on the set theory, which are also hold, and it makes some kind of conjectures. For instance, we can define a set. The paradox theory will be tell us about some sets. For instance, if A is a member of A, if and only if A is not a member of A. So this kind of conditions we can define, which is also hold for a set, like A is a member of A if and only if A is not a member of A. And this can also make some interesting results on that one. Though you can drop this kind of paradox theory because it's not the part of his syllabus. But it's interesting to understand the idea that we can still define A belongs to A, for which A does not belongs to the A. So this kind of the paradox theory we can see, and we can say about the conclusions regarding this paradox sets. Okay, but meanwhile these are not in the part of syllabus. But on the other side, you can see that if some there are some sets that are not a member of themselves. Like, for instance, the set of cats. The set of cat is not a member of itself because the set of cat is not a cat. Like if Y is a set of all cats, then Y is not belongs to the Y because set is not itself a cat. And if on the other side, this is sometimes true. For example, if X is the collection of all sets, then collection of set is also a set, then it means X belongs to the X. So these kind of things are the conditions or things also be satisfied sometimes. And also one can describe the some of the sets. For example, if A is a set where X is not a member of X. Now it means this means that if A belongs to the A, if and only if A it does not belongs to the A, it's basically this type of a theory will be related to the paradox theory. So again, I'm telling you that this kind of the paradox theory is not a part of a syllabus. So the next topic we will consider about the functions, but I'm thinking that the next week I make another session about the functions and describe some problems related to the functions, because the functions, definition of functions, then their correspondence, then onto functions, one functions. So this we will discuss in the next session. And regarding the problems of a some questions like give an example of a set for which uh, there is a set B where B belongs to the A, but B does not. B is not a subset of A. And also, you can make a certain kind of that sets and give an example of a set A such that there is a set B with B is contained in A, but B does not belong to the A. So this is the simple example. You can make many examples in that form. So also the next problem is regarding the calculations of a power subsets. Like power set is a set for power set of this set contains an element phi, and then the power set is also a set because it's a power set is a collection of sets, possible collection of a all possible collection of a set, which is also a set. So these are some problems which are related to that one. And there are also some sets which are basically the conditional based sets which we can describe, and we can consider this like if the x square is a set, like 4 is less than equal to x square, so it means it contains all those elements which are which are greater than x square, so you can describe the some that kind of particular interval. So but we will describe the functions, the definition of a functions, their 1 1 on to 1 1 correspondence, their composition, their inverse in the next session. So we finished the first session, which is about the set theory and its relations. If you have any question, you can ask your question now about this topic. Or yes, please.
Hello.
Yes, I can hear you. Yes, please.
I wanted to ask. I was late for the session, so I just wanted to find out if there's gonna be a recording for the session.
Yes, this session is already in the recording. So after completing of that session, the recording will be posted in the My Module website in the announcement. So you can follow the recording of that session from the website, My Module website of MAT2611.
Okay, thank you.
Yes. Any other question?
Yes, sir. Just to, yeah, sir, I wanted to find out. You said Russell's paradox is not part of the syllabus. Is it the only topic that we have covered that is not part of the syllabus?
Yes, actually, the paradox is actually this makes some conjunctions like for instance, X belongs to the A if and only if X does not belong to the A. Such kind of a paradox, which are hold like in the definition of a set, but in general, these make certain kind of conjectures. So this is not the part of a syllabus.
Thank you, sir.
Fine, I saw that. Please, like there are some comments like, please, sir, slow down. You are moving fast. Basically, it's some set theory and the basic topic. So in the next session, I will go a little bit slow. But meanwhile, I am also sharing you the recording, so you can follow the things. And there is a question that can you repeat the definition of a distinct set? Uh, Basically, distinct sets are mean distinct mean different set. Set is actually the collection of well-defined and distinct elements. So this is the good question I appreciate, and I again tell to you that please focus on the two words. One is well-defined, and the other is distinct. So well-defined mean all those elements which are properly defined. You cannot be make a collection of those elements which are not well-defined or ill-defined. For instance, if this thing may be happening or not, then if the element is doubtful, then you can't be included in any set. For instance, someone asks you that make a list of his students which are enrolled in MAT 2611. Suppose that someone asks you make a list of students which are which joined some university or which are the part of that set, which joined the course MAT 2611. And suppose that we include a list of those students or set of those students which are enrolled in MAT 2611, but some students we are doubtful. Like maybe student X is enrolled or not, Y is enrolled or not. But still, if we include in that collection, then it means that collection is just collection, but not a set, because the elements are not well defined. We are not sure that these are either the part of the element, part of the set or not. So this will be mean that well defined. And the distinct elements mean the element will be not repeated or not be, suppose like the element should be the distinct. For instance, if you make a set 1 comma 1 comma 2 3, it means that 1 1 is repeated and 1 1 is not it's not allowed. Every set has a unique representation, like 1 2 3, that's all. And so that's is the important reason. And so that's why in set of real number, the infinities are not included, because as I told you, that infinity is equal to infinity plus 1. Infinity is also equal to infinity square. So the infinity plus infinity is not the element which is distinct. So that's why we exclude the infinities from the set of real number, because it's if we include the infinity from that one, so it violate it can be become a collection but not be the set, because the set only contains the elements which are well defined as well as distinct. Any other question? How you often so okay, so the lessons will be announced a few days before on the announcement of a
Hello, sir.
announcement on the website. Yes, please.
How are you?
Fine. Yes, please.
Just wanted you to verify something for me here. When you said we have two sets, for instance, we have set A and set B, and then you said that set A is a proper subset of set B. Does that mean there are no elements of A which belongs to B?
No, no, no. If we say A is a proper subset of B, then it means that there are some elements on a B which are not the element of A. For instance, here I can tell you that A contains look 1 2 3, and B contains the only one. Then it means this B is a proper subset of A.
So the notation, please, sir, can you write it? Can you show me the notation here? Because the notation that I got, maybe it's confusing for me because you said A, then proper subset of B.
Yes, look, this mean yes, proper subset means we can say that A is a proper subset of B. It means there are some elements in B which cannot be in A. And on the
Oh,
other hand, if we say that A is a improper subset of B, it means there is a chance or possibility that A and B can be equal. Either A is a subset of B or A is equal to B.
oh, okay, it makes sense now. I thought that when we said A is a proper subset of B, there are no elements of A that belongs to B.
Yes. So look here, we can say that in this case, like your A is 1, 2, 3, and B is only the one. It means A is a proper subset of B, but A is not improper. Like let me make a slash on that. It means it's not a proper. I hope you understand that if A is a proper subset of B, it means B have some other elements which are not in A. Like in this, you can see that
Okay.
if we take B like this and A like this. Yes. And on the other thing that if A and B are the improper subsets of each other, then it means A is equal to B.
Okay. Thank you.
Okay,
Thank
so
you.
about the sessions or lessons, so I will in the what I will do is that a few days before you will get announcement on the Moodle website. Also in the Telegram, I will show the announcement and the time and the date of a session, and you can join the session as well as after the session you can see the recording of these sessions on the my module website. The link will be provided to you on the my module website. A is an element of there is a question that A is an element of B, but A is not a subset of B. Okay, so here you can see that A is an we have a yes, there are some examples. Look, if A is a A contains some elements like A is equal to the A. Like for the simplicity, you can just take A is 1 and B contains like 1 and the 2. So 1 in this way. It means A also contains its element which is set and the other is the entry of that. So now you can see that this A belongs to the B, but this A is not this A belongs to that one, but this A is a subset of C as well because you can see that this is also a subset and as well as A belongs to this one. And on the other hand, A is not a subset of C. Like you can see that because A is contains the element of that one, which is one element, and uh, C is the thing which is like in this way, which have the entry of that one. So this is the thing that when we say belongs to that one, it means the this it will be the part of this set. Like the whole set is an element which is belongs to the C. So this is basically about that one. You just need to be
So say
focused. Yes,
of C in that case, but it does not belong to C.
yes. Like look, if we say that A is a set having this, so B is also that one. You have to notice that if this is some, if you say A is equal to the X, then it means A belongs to the B. Also, A belongs to the C. And subset is the something else like A is not a subset of B and A is not a subset of C in that case. For instance, the subset in if you have this thing, then let me make another example. For instance, if we have another set A which contains 1 and we have another set B which contains the two element 1, 2 and we have another set C which contains like 1, 2, 3. Now you have noticed that the A is a subset of proper subset of B. B is a proper subset of C. But this A does not belong to the B. This A does not belong to the C. This B does not belong to the C. Like here, I just put it the notions that A is a proper subset of B. Also, B is the proper subset of C. These things are hold. But in the above example, here you can see that this the A this A belongs to the B because this is the element of a B. And this B is B, one can see that B is a proper subset of C because the element of B are also the element of a C. So you can see that B is a proper subset of C. Here in this case, this is true. But for this example, you can see this is the separate example for which you have to be noticed that if we take these sets, then A belongs to the B and B belongs to the C. So so A is a proper subset of B and B is a proper subset of C. But in this case, we can't say that A belongs to the B or B belongs to the C. Only we can say that A is a subset of B, B is a subset of C. I will also upload these notes on the website and you can follow from the website. Yes, please. Any other question? Okay, if there is no question, then fine. So I will upload the. Yes, please.
On the example that we
Sir,
just discussed now,
Uh,
if we then add another set, call it D, and that set contains a set which is 1, 2,
okay.
we have a set D that
Okay.
contains,
Yes. D contains what?
it contains a set which is 1 and 2.
Okay. Then 1 and 2 is equal to the B. So
Uh,
it means
Can we put a bracket outside of that set?
which one? Like 1?
Uh, like the set of 1 and 2 should be inside a set or should be inside the bracket.
Okay. Yes. Fine. Now we have to see that. Is this complete now? Is the set
Yes,
B
sir.
complete? Okay, fine. Now let's see. This B is the element of a D. So we can see that about the B belongs to the D. Can you see that? Because this is the set, but meanwhile in this set, this this becomes element of a D. So D contains one element which is itself a set B. So it means B belongs to the D. Now, can anyone tell me that is A belongs to the D or not?
It
What
does
is
not, sir.
yes,
A
yes,
belongs to the D or not?
yes,
It
it
does
does.
not, sir.
Very good. So
Well,
it does not.
should
It said,
Does not.
can,
Why?
it does
Because
not.
look, it does not. Excellent. Because this is itself an element. Suppose you say this is Y. So this, if this is Y, then Y does not belongs to the D. Okay, so this is the thing. And what about the B? We can say that belongs to the D. C and D are distinct. So yes, this makes the sense and this make the information.
Okay.
Okay. Can someone tell me is A belongs to the C or not?
It does
no,
not, sir.
Not.
Well done. Not. A also does not belongs to the C. Well, so these are the relations for belongs and subsets. So any other
Uh,
question?
Sir, may I please get clarity on something?
One by one, please. Yes, please.
No, she can
no,
speak. I'll speak after her.
Okay, so since B is an element of D in this scenario, does that mean B is not a subset of D?
Yeah,
Or am
B
I wrong?
definitely. B actually. There is a two thing. Yes, you are right. Like on the other besides, B is also a subset, a proper subset of D. Why? Because B contains 1, 2, and these 1, 2, these are the elements. And the same elements 1, 2 are over here. So we conclude that B is also a proper subset of D. Yes, you are right. Yes, any other question?
so,
So,
so, say,
I wanna,
Yes,
I
please,
wanted
one
to
by
get
one.
clarity on something. What I was asking is, since you were saying that was this in this particular case, A is not an element of D, but does that mean that like then the visual elements of A are also the same as the element of D? And how would we denote that in terms of notation? Because the elements of A are in the element of D.
Yes, but you have to be noticed that A is itself a collection which contains one. So collection is one
Okay.
thing, and these are the element. This is also the collection one and two. But these are element. You remember that I have somewhere mentioned that this one set and this one is not equal because this one means like identity, and this one mean a class which has one
Oh,
element. This is a
okay,
class.
okay,
Okay.
okay. No.
So
So say in simpler terms, is A a subset of C or not?
A is a subset of C. This is correct. Why? Because the element of A is also the element of a C. So yes, you're right. Even we mentioned that A is element of a B and B is element of C. It means A is also a subset of
Now I'm
C.
lost now. I'm lost now, say.
Yes. Any question?
Ayo. Say, hello.
Yes, I can hear you. Yes, please.
Yes, now I'm lost now. You said that before that you said that A is not a subset of C.
A
You
is
said that A is not an element of C.
no, I told you that A is a subset of B and B is a subset of C. Like it's A is also a subset of C. But
Okay,
A
it's
does
fine.
not belongs to the C.
It's fine.
Okay,
Thank you.
welcome. So, is there any other question?
Sir, is I a subset of D?
Uh, please say again.
Is I a subset of D?
This A is not a subset of A. A is not is yes. This A is subset of D as well because A contains the element, one element, a class, and B is a class which is bigger class, like it has other elements which are also in D. So we conclude that this A is also a proper subset of D. Yes, this is also the true. You have note that A contains sorry, A contains only one element, D contains the three elements. So there are three elements in D where the element of A is also the element of a D.
Sir, sir, can you hear me?
Yes, yes.
Can you please give an example of from this same example, but give a condition whereby is not maybe A is not a subset of B or whichever you can choose whichever set here just to give an example of a condition of not a subset of something.
Not a subset of something. Like here
Yes.
you can see that, for instance, this B is a subset of that one, and suppose that let us make another set uh, E, which contains, for instance, 1, 2, and say another element. You means that which is not a subset or not belongs?
Not a subset.
Okay, not a subset. For this A is a subset of B, A is also subset of C, A is a subset of this B, C. You have noticed that this, if we make D like this C is not a subset of D. Can you notice that? I think this cover also this case. This C is not a subset of D. Why? Because there are some elements in C which are not in D.
Oh, oh, I
Because
see. I see.
three is an element which is not in D.
Yes.
Okay, fine. So, okay, we are now stopping this session. So, if you have any question, you can. There is also the forum on a MAT2611, which you can ask your question or make a discussion on that. So, in next week, we will make another session which deals with the questions and the problems, examples related to the theory of a functions, because if we have a set or two sets, then we can define a function or some correspondence. Sometimes they are one, sometimes they are on two, sometimes they are bijective. Then also we'll see the inverse of that functions and composition of that functions. And we also describe some questions related to the functions. Okay, in the next session. Okay, goodbye now, and we will see next week. And the announcement and the link will be shared to you on the Telegram groups as well as the announcement on a MAT2611 website. Okay, have a wonderful day and goodbye.